So today what I would like to go over are mixtures and also how to separate mixtures. So there's two different types of mixtures. There are homogeneous mixtures and heterogeneous mixtures. Now, homogeneous mixtures consist of what we refer to sometimes as one phase. And if you look at these two pictures down here, here we have brass, which is actually a homogeneous mixture of copper and zinc. So if you look at this piece of brass, the brass itself, you don't see different parts, and that's what we refer to as one phase. We see the same thing here with this vinegar. The vinegar is a solution of water and acetic acid. And if we look at the different parts of the vinegar, they would all kind of taste the same, they would all look the same. So again, we say that it has one phase. Now, if we look at heterogeneous mixtures, these have more than one phase. And that means they have visible parts. So if we look at this iced tea down here, we see that it has ice cubes, and an ice cube is going to be all frozen water. And then we look at the tea itself, which has a different composition than the ice cubes. So we say that it has more than one phase, and the two different phases happen to be different states of matter also. But if we look at these cookies with these M&Ms in it up here, we see that it also has two phases. They're both solid in this case. One of them is going to have a candy coating with some chocolate in the center. The other part is going to be your cookie dough that's been cooked. So these have visible parts, and in this case, it'd be very easy to take those M&Ms out and just eat the chocolate. I mean the cookie without the M&Ms. Likewise, we could take the ice cubes out of our iced tea and drink the tea without the ice cubes. Here, the visible parts, here's some sand, are not as obvious, but you could take those little black specks out of the sand if you're very patient, probably with tweezers. And so it has visible parts. And up here, this one, it would not be as obvious to your eyes, but this is blood. But you could actually take out those little red blood cells. So it has more than one phase. The red blood cells are made up differently from the plasma in between and then the white blood cells. Okay, so those are all heterogeneous mixtures. So they will have different parts which may be very visible to the eyes, may not be as obvious. You might need a microscope to see the different parts, but there are visible parts. So, okay, so there's different ways we could separate your mixtures. Some of these are defined in the book, and I'm assuming that you guys are very familiar with them. For example, filtration. If any of you have a coffee maker at home, you have a filter on that. So everyone should know how that works. Vaporization is where you have a situation where you're evaporating the liquid portion and you're leaving the solid behind. So if you had salt water, that would be a way to separate your salt from the water to recover the salt. The next one you're probably not so familiar with is decanting. Now, this is where you might have two liquids that are separated, like oil and water, and you would pour off one of the liquids to leave the other liquid behind. Or you might have a situation where you have maybe some sand and water. Obviously, sand does not dissolve in water, but again, you could pour off the water and leave the sand behind. So that's how that works. Centrifugation or a centrifuge is just a machine that spins samples very, very quickly. And then the different densities in your sample, the materials of different densities will separate. And sometimes you see centrifuges being used, maybe on a show like CSI, where they do some lab work. and this can be used to separate different parts of a blood sample from each other. The next one is distillation, and I'm actually going to show you a video of distillation. But what we use this for is we separate different liquids, sometimes based on their boiling points, or in the case of something like distilled water, we can purify the water by separating out maybe some dissolved salts that are present in the water and just getting the pure water afterwards. So let me just show you a video of this process, which will make a little bit more sense, and then we'll go over a few more separation techniques. Okay, guys, I want you to watch this video and just take notes.
When performing a distillation, first the condenser is filled with cold running water. Next, heat is applied to the mixture which is to be distilled. The mixture is heated until it boils, and the hot vapors will travel up the distillation head. Measuring the temperature of the vapors helps us to identify the liquid being distilled and will help to confirm its purity. If the vapors are pure, they will have a constant temperature equal to the boiling point of the liquid being distilled. As the vapors travel into the condenser, they will be cooled and will liquefy. The liquid droplets, called the distillate, run down the condenser and are collected in a receiving flask. A liquid can be easily separated from non-volatile contaminants by using a simple distillation apparatus such as this one. Since the non-volatile components in the distillation flask will not evaporate, the vapors and the resulting condensate will be pure.
Okay, I want to go through two more types of separation techniques for mixtures. One of them is chromatography. So, this is something you guys probably did when you were a little kid, maybe for your mother for like Mother's Day, where you might have gotten a coffee filter, put some ink on it, soak that in water, and then the ink would spread out and make like a pretty pattern on it. So, black ink is actually composed of pretty much every color in the rainbow, and you can separate those different colors of ink from in the black ink by using chromatography. So here, the first picture here, we have a line drawn with black ink. We put this in a little tray with some water in it. The water moves up the paper, and as the water moves up the paper, the ink goes with it. Some ink is very attracted to the paper. So here the yellow ink is very attracted to the paper and will kind of stay at the bottom. Some ink is very attracted to the water and will travel up the paper. So we see the blue ink was very attracted to the water and traveled all the way up the paper. And then we see the different inks that made up the black ink after they are separated. So that is chromatography. An advanced form of this technique is when they look at DNA samples from a crime scene, they actually can separate those using chromatography. The last separation technique is very basic. If you have a metal that is present in your mixture that's magnetic, you can actually separate that out using a magnet. And one thing you could try at home is if you have any kind of iron fortified cereal, if you crush that up very finely and put that in water, put a magnet into that mixture, what you will see is the magnet will attract little pieces of iron that were in your cereal. And I've tried this and it does work. It's pretty cool. Okay, so now what I want you to do is on the next slide, let me bring this up. I want you to think about these now, thinking about everything we've talked about. Think about if these are elements or compounds. So if they're an element, you need to use your periodic table to see if you see it on your periodic table. That should easily identify your elements. Your compounds, you're going to usually see a formula there, or you might know from your experience that it's a compound. If they're not a pure substance, they're not one of these. then you need to see if they're a mixture. If they're a mixture, you need to see if it's homogeneous or heterogeneous. So let me just bring this up, and I'll just show you for the first one. So if we look at air, air is not on the periodic table. Also, air, we know from our experience, probably in earth science, that it's not a pure substance, that there's different gases in air. So this tells it's not a pure substance, so it's a mixture. So we're going to write down mixture. Okay, so since it's a mixture, we have to think about, is it homogeneous? Is it the same throughout? Or is it heterogeneous? Now, gases, you can assume, are going to be homogeneous. So since this is a mixture of gases, we know it's homogeneous. Now, if we do another one, let's look at sugar and water. Here we have two substances, so we know it's not a pure substance. So again, it has to be a mixture. And typically things that are just that dissolve in water will be homogeneous, so we know it's homogeneous. Now we come down here, we look at chlorine. We know that chlorine is on our periodic table, so this is a pure substance. And since it's on our periodic table, we know it's an element. Down here, hopefully you guys remember from biology, this is a compound. So this is a pure substance. And this is a compound. Okay, so I want you to try all these. So think about that. Is it on your periodic table? If it's on your periodic table, it is a pure substance and it's an element. If you know from your experience it's a compound, then you know it's a pure substance and it's a compound. Otherwise, you have a mixture, and then you have to think about, is it the same throughout, or do you see different parts of it? So try those. Pause the screencast and then come back on and we're going to go over these. Okay, so let's go over these. So wood, this is obviously not a pure substance. It's going to be a mixture. So I'm put down mix. And if you think about, wood has different parts. There's like knots in it. There's grains. So it's heterogeneous. We look at granite. If you have a piece of granite in your kitchen at home, you know it has different parts. So it's not a pure substance. It's a mixture. And since we see different parts, it has different phases. It's going to be heterogeneous. Next one, aluminum. That's on your periodic table, so we know it's a pure substance. And we know it's an element. Blood, we saw that in the slide. That's a mixture. And it's hetero. Stainless steel is actually a mixture. And it's a homogeneous mixture. We call that an alloy. So here's a term, probably want to write down. This is a homogeneous mixture of metals. Sodium chloride is a pure substance, and it's a compound. Brass is another alloy, so that's a mix, and it's homogeneous. Whole milk in the United States is a mixture, and it's homogeneous. Apple is also a mix, and we think about, you have the skin, the core, and everything, so it's heterogeneous. You see different parts. Table salt that's sodium chloride. So again, that's a pure substance. And it's homogeneous. Excuse me, a compound. Sorry about that. Soft drinks, you have the carbonation, you have the sugar, you have the syrup. That's going to be heterogeneous. Because you think about the bubbles and everything, there's different parts to it. You see different phases. Vinegar is going to be a mix. And we did this in the slides. That's going to be homogeneous. Concrete is also a mix. And since sometimes they mix rocks in like an aggregate, I would say it's probably heterogeneous. Sodium is on the periodic table, so it's a pure substance. And it is an element. Here we have a pure substance, all right, PS, and compound. Last one, gravel, you see different parts. I would say it's a mixture, and I would say it's heterogeneous.